welcome back. And so here's video notes number 2. Let's continue on where we were. Hopefully you did this one and you noticed that the graph started at the origin here, and now the vertex has moved over to the right 2. And what eventually you're going to want to be able to do is say, okay, this equation looks like this. From the parent function of x squared, it has moved down by 3. So I can, or up, I'm sorry, up by 3 because it's a plus. It's moved up by 3. So I can tell that this graph is going to be very similar to the parent function, except for it's going to have moved up 3. And this one is very similar to the parent function, except for there's this 2 that's inside the parentheses. And that caused the entire parabola to shift to the right. So that you can tell just by the equations how this parabola, how this parent function right here is moving around and what happens when you add numbers to the parent function to move it around. Okay? So if you haven't already gotten that down, stop your video, get it down, and let's move on. So now we're going to see, okay, what happens when there's a negative in front of the x? And what happens there is you have f of negative 4 equals negative 4 squared, and that's going to be positive 16 with the negative out here, so negative 16. And then f of negative 3 is going to be negative 3 squared, which is negative 9. F of negative 2 is going to be negative of negative 2 squared, which 2 squared is, negative 2 squared is positive 4. Negative out here, negative 4. F of negative 1 is going to be negative 1. F of 0 is going to be 0. Now, what happens when we get to positive numbers? This is going to be f of 1 squared. Now, keep in mind, you're squaring first. The negative comes after, so this is still going to be negative 1. This is f of 2, and if it makes you feel better, you can put that 2 in the parentheses. You're squaring the 2 first, getting 4, and then this negative comes after. The negative portion of this is not getting squared. So it's going to be negative 9 and negative 16. Okay? So when you have that, basically you graph that. Your vertex is going to be at 0, 0, 1, negative 1, negative 1, negative 1, 2, negative 4, negative 2, negative 4, 3, negative 9, negative 3, negative 9. And it's going to look like that. Okay? Moving on, what if the parentheses is inside? Well, that's a different story because now we've got negative 4 equals negative 4 squared. That becomes actually positive 4 squared, which is 16. And again, negative f3 is negative 3 squared. This becomes positive 3 squared, which is 9. F of negative 2, negative 2, which is going to be positive, 4. And then f of negative 1, which is going to be negative 1, but the parentheses is inside, squared, positive, f of 0, 0. And then you just start getting positive. So even though we have positive 1, negative 1 squared, negative positive 1 is still going to be negative 1 times negative 1, which is positive 1. f of 2, negative 2 squared is negative 2 times negative 2, which is positive 4. Now the reason why this negative doesn't change it is when we are graphing it, it actually flipped it going this way. So it flipped it over the y-axis. This negative flipped it over the x-axis. This flipped it over the y-axis. So you aren't able to really see the difference. But if you really care, if this side was the star side and this was the 3 dot side, this would have become the 3 dot side and this would have become the star side. Okay, that's how it flipped as opposed to the other way. All right, and so you can't see it with your eyes. Now here, this is a 3x squared, so we're going to just do the same thing. F of negative 4 equals 3 times negative 4 squared. We're squaring first, so this would be 3 times 16, which is 48. 3 times 9, which is 27. 3 times 4, which is 12. 3 times 1, which is 3. 3 times 0 is 0. 3. 3 times 2 squared, which is 3 times 4, which is 12. 3 times 3 squared, which is 27. And 3 times 4 squared, which is 48. So to graph that, you're going to, again, start at your vertex is still at the origin, but you're going to go over 1, up 1, 2, 3. And you're going to notice that this is way skinnier. It's stretched out. This is a vertical stretch. It's stretched out. It's getting long and skinny. All right? So there's that. So if we were going to name these, this would be your parent function, where it's the vertex is at the origin. All right. This would be translated up 3 units. So the vertex is up 3 units. Vertex up 3. In this situation, your parent function translated to the right 2 units. So translation, right 2 units. In this one, this is called a reflection across the x-axis. And in this one, this is a reflection across the y-axis. And this one here is a vertical stretch. Okay, that's it for this video.